All right, so here we're on 3.2 on compound and continuous compound interest. So we'll work some exercises here. All right, so the first thing we want to do compound interest. So we have a principal, we have an interest rate, we have a number of compounding periods, and we're supposed to find the future value. So for simple compound interest, what we're going to do is we're going to use the formula A equals P times 1 plus I to the n power. Okay, so we just have to plug in everything that we know and solve for A. So A is equal to P, which is the 2800, and then times 1 plus 0.003 and raised to the 24. Now, plugging that into our calculator, we have 2800 times, then we have 1 plus zero point zero zero 0.003, and then raised to the power 24. So we get 3008 and then 71 cents. So that gives us 3008 and 71 cents. And that's just plain compound interest. What about something like continuous compounding interest here? All right, so with this one, what we have to do is use a new formula. Now, the new formula we're going to use is, if I can find my writing place, here it is, A equals PE to the RT. So easy way to remember is PERT, and so it's P principal times the exponent of R to the T power. And so this one, in this case, they want us to solve for P. This one, they want us to solve for R. Sometimes they want us to solve for A. All depends on what they're asking for. All we have to do is rearrange the equation. So they say, okay, well, let's say we have 19,000 equals P, which was what we're looking for, E to the 0.0769 times 5. Okay. Now, to solve for P, we just have to divide by e to the 0.0769 times 5 and divide that by e to the 0.0769 times 5. Okay. And when we do that, we get P is equal to, and let's go check that out so we know how to do it on our calculators. All right, so clear. And so we had 19,000 divided by, and now we have E, which is this button here. The E is blue, so we second ln, and now we take it the 0.0769 times 5. And if you have an older style calculator, you'll want to put everything up here in parentheses. With the new ones where it takes everything up to the exponent, you don't have to. And we get $12,935, and if we round it to the penny, and 3 cents. So that one gives us $12,935.03. Well, what about this one where we have to solve for r? Notice r here is in an exponent, and so we just can't do some simple math. We have to do some actual logarithms and things like that. And so we plug it all in. We get 23,600 equals 19,150 e to the, now we have 60 months, so we'll put in that as years. And so that's equal to how many years? Well, that's 5 years. And so it's e to the 5r. Okay. Now we need to solve for r, so we divide both sides by 19,150. And so we have 23,600 over 19,150 equals e to the 5r. Now, with logarithms, what we can do is we can take the ln of this side, and when we do that, we can take what's up here and bring it down front. But if we take the ln of this side, we also have to take the ln of that side. So now what we have is on the left, the ln of 23,600 over 19,150, and then equals. Now, this, when you do it, it gives you 5r ln of e. Well, ln of e is just 1, so this is just 5r. Okay. Now, if we divide both sides by 5, we get our final answer. And so r is this division. So we'll do it two ways. We'll do it like we just did it here with logarithms, and we'll also do it with our numeric solver. All right, so this way we're going to have ln, and we have 23,600 divided by 19,150, and then that is all divided by 5, and we get 4.179% if we're going out to three decimals like they usually are asking us to do. Now, the other way we can do this is math, arrow up, numeric solver, and we plug everything in here. So that side was going to be our 23,600. Now this side, let's clear all that out. And that was going to be 19,150, and then e to the 5x. Okay. And now we've got that. We can hit this graph. It is okay. So we hit graph here, we hit here, and this is what we get here. 4179 again. So either way you do it, you get the same answer. And so let's go ahead and write that over here. So we get 4.179%. And that is our rate for this problem. All right, let's stop there and we'll come back for some more.